Hello ladies and gentlemen, welcome to another video on this channel. This episode is going to be a banger because this marks the release day of the beta files of my open source hotend, which you can build and use by yourself. I will show what kind of crazy things you can print with this kind of hotend, and by the time of the release of this video I will have filed a patent over it. So let's discuss directional material deposition. My name is Jan. I build stuff so you don't have to. So starting off with what is DMD? Our journey starts here at the Creality CR10 Max, which I've repurposed to fit the hotend in question. I followed Teaching Tech's Klipper flashing guide, which I'll be linking down in the video description, and hooked up this Raspberry Pi 5 to the original Creality mainboard. The very first print I did with this setup was this 100mm cube in vase mode. The result still blows me away. I would have never imagined it working this good. We can build multicolored parts without any filament switching, priming towers or printer's poop. It is wasteless. The way we achieve that in very short terms is co-extrusion. The hotend does feature 4 inlets which can be equipped with any sort of filament combination, either different colors or entirely different raw materials. Since the hotend is SLM printed in solid aluminum, we do have all the design freedom imaginable. Both most outer filament paths lead to the 0 and 180 degrees section of the outlet. The inner path, however, do take some turns and ultimately are being fed to the 90 and to 70 degree position of the circular outlet. Since we do encounter laminar flow in the melt channel, the colors are very cleanly separated at the outlet, pretty much like a pie, split in 4 symmetrical sections. With the nozzle orientation being fixed in regard to a printer's coordinate system, we get control over which filament is visible as the most outer perimeter, thus creating material deposition in accordance with the movement direction of the printer. And I know this seems a bit of a brain fuck, and indeed it is. So let me try to give you a crude analogy with pen and papers here on how this actually works and which colors can be seen from the outside. So let's say you have loaded up any kind of 4 filament or 4 raw materials, whatever. The output will look something like a pie that has been cut into 4 corners. So let's assume this is a nozzle output. I taped together 4 pens. The way these will come together from the hotend is something like this, and then if I try to draw a circle with all the 4 pens touching, I missed the yellow one, but you can clearly see which colors are can be seen from the outside. The violet is here on the far right hand side, blue is on top, black to the left, and orange will show up here. Okay, one step further, let's see what happens if we're not moving in the printer's X and Y direction rather than moving diagonally. So what you can see now is that 2 filaments are being visible from the outside, and they're still not being mixed, but they're overlaid on top of each other just like your RGB lighting in a TV or something does it. It tricks your brain into thinking this is a distinct color. Of course you can see this is black and orange somehow overlaid, and this is black and blue. So basically, by adjusting the angle, you can pretty much dial in every color gradient from these 2 neighboring colors. You can't do full CMYK or something because you would need all 4 filaments being deposited on the outside of the print. But you can do any sort of color range between this purple and this orange, or orange and black and blue. You get it. But there's way more to it. Let me show you. I tested my pen and paper theory by printing this gradient test. Every increment is an additional 10 degree of angle. The result is a gradient between both most outer and neighboring filament streams. That's part of the brainfuck. The consistency of the gradient was mind-blowing, and I immediately started to investigate which kind of colors can be created by this method. In this case, the answer is pretty easy. We can get a full display of possibilities by printing a circle. This shows pretty much every possible color that we can do extrude with the 4 filaments chosen depending on the movement direction. Of course, I was dying to see a more technical and real-world print, so I printed two 3D benchies at 200% scale. Everything you see here today is being run with a 1mm nozzle installed and at 0.5mm layer height. One of the benchies is being printed at 0° orientation on the print bed, the other at 45 degrees. Afterwards, I loaded up 4 colors of PETG and printed some big ass single line vases. I realized that I didn't have this much fun watching a printer since basically forever. The results are mind-blowing. At every angle of the print it does look different, and there is pretty much no way to achieve the same result with conventional methods. Also, it's pretty fast. In the most extreme test, I was able to run the Hotend with a max flow of 200 cubic millimeters per second. Moving on, I printed a pyramid to investigate how the visible deposition changes regarding the angle of the z-axis direction. With very low contrast colors, the effect does diminish a bit, since you can see small parts of the previous layer peeking out. But this could be counteracted with a lower layer height initially. I also printed a similar looking pyramid, but this time tried to find a way to get around a very common problem of state-of-the-art printers with multi-filament feet, only coloring one part of a vertical wall. For this, I loaded up 3 black and 1 orange PLA filament, which came out with a brownish color after all. The result is a pretty clear separation of the 4 sides of the filament and the front being highlighted. Also, the embossed logo does feature a lot of contrast since it contains a black portion on the protruding sides. The remaining problem now? The top and bottom surfaces are looking a bit out of place compared to the clean outer walls. I moved on with my investigation on how to manipulate the third dimension of the material deposition to control the most outer visible layers in the top and bottom surfaces. In these first 2 prints, I was running it parallel to the x-axis, the first one top to bottom and vice versa on the second. Not a big difference there, only slightly at the edges. It struck me when I tried a circular infill pattern. The orange filament is feeding into the first channel, which is pointing straight at your screen. By moving in this direction, the orange part is being deposited straight down at the print bed. If we move in the opposite direction, the orange turns out on top. As far as I know, there is no native infill pattern that does run in only one direction, but this is only one script away and could easily make it into slicers in the future. Have a look at how great this works if I flip this piece. So it's black here, and it's brownish orange-like on the other side. The last thing I've tried is actually using different materials altogether. There is still so much to explore, but I wanted to give a hint at what is possible. Both outer lanes are fed with TPU, the inner ones with PLA. After a bit of fooling around with temperatures, I created a part that can be considered pretty tough. It's a weird combination of stiff in its core, but also soft on the outside. A good analogy would be a boner after a few beers. Does that make sense? But we need way more scientific investigation on these material combinations, and I'm working on that on the background. Also, I want to give you guys an open field to play with and make your own discoveries. You know, we had to talk about this at some point, and I've been spoiling you in the intro of the video. What we are doing today is filing a defensive publication. What that means is, we pretty much publish all of our findings online and create prior art. After that, no one else will be able to file a patent and hide it away from the public. So just a short disclaimer before we move ahead. Patent research is either very hard or very expensive. If I've missed something in my research work and your patent has already been filed but not yet published or something, I don't want to discredit or steal anyone's work here. So if that is the case, there's an email somewhere down in my channel description, write me something and we'll figure it out, okay? So, just like in a formal patent, we set up claims now. The A1 claim is pretty much the essence of what we've discovered. I came up with this. A method of co-extruding multiple filaments in additive manufacturing, wherein the deposition of each filament is actively controlled based on the movement direction of the printhead, enabling directional placement of distinct materials or colors. The core claim is then being followed by some dependent claims, which show some more in-depth solutions as well as applications. I came up with the following. The method of claim 1, wherein the extrusion head provides multiple independent melt channels for selectively depositing any number of materials or colors in coordination with print path direction. And maybe even more importantly, the method of claim 1, further compromising a rotational axis, implemented as a rotatable build platform, extrusion head or nozzle, thereby enabling freely controlled spatial orientation of directional material deposition. So think about it and let that sink in. Like, if we take this approach and move either the build plate or the hot end altogether, we can pretty much put any color gradient at any place of the print. So I think we do have a lot of content coming up on this endeavor, so maybe it would be a great idea to consider subscribing to this channel. So lastly, this video will serve as a publication to make this all prior art. And I want to encourage you to go down in the comment section, type everything down there, what we should claim on top of that. And we'll do another video to further enhance our research. Another great way to get in contact with me is my Discord channel. There will be a link somewhere down in the video description, as well as a link that leads to my Patreon site, which helps me tremendously in doing all of this as non-profit research. If you come up with even more use cases, we can do a follow-up publication and claim even more that will be available to the public forever. Okay, for acquiring all the parts needed for this hot end to actually run on your machine, there are several ways. One of them is our today's video sponsor, PCBWay. PCBWay is an online platform that does manufacture a lot of stuff, including PCB manufacturing, CNC machining, sheet metal, and of course 3D printing. We're going to make use of that and have the main components as well as some accessories manufactured by them. On the GitHub, you can also get the raw STL files and have them printed wherever you desire. But there is a link in the video description where you can get a fully configured basket where all the threads tolerances are already locked. The main parts are the SLM printed hot and cold end, both manufactured in solid aluminum. What I'm holding in my hands here is the 2-filament version, which I'll be airing in the next video. This will go on the Prusa Mark III, but with the Prusa being highly modified, I will run small nozzles and very high speeds with it. This is the 4X version, which is also on the Creality. We're going to have a look at that in a second. And as you can see, the quality of these parts in aluminum is top notch. Another part is this back brace here, which you can put on something like this, and then there is a connection point up here on the cold end. But in my testing, I didn't find this to be necessary, but if you guys are into very stiff hot ends, you can have this ordered as well. So as always, I'm not just making that up. I'm really impressed with the quality and the speed of delivery of these parts. So again, a huge shout out to PCBWay for sponsoring this kind of content. Let's go to the machine. And yeah, to make this happen, you of course need some different items. Let me show you what this looks like by disassembling the setup I have on my CR10 right now and discuss the individual parts. Alright, starting from the top, this extruder is basically the start here. This is brought to life by Bondtech. Right now this unit is a one-off and it will become a product in the future. It does feature 4 inlets that are being driven by a single motor and connected drive gears inside. And for it being the first prototype of this series, this did run surprisingly well and hold up to all the tests I've been conducting here. However, I don't own any Bondtech stocks. I don't have any idea when this is going to be available and what it will cost. And up to this point, the only alternative is to prototype something for yourself. The Hotend is designed that it is possible to use either a direct drive or a Bowden setup. And if you want something easy to start experimenting, I would suggest to just parallelly run 4 Bowden extruders on 1 or more driver channels and let them do just their thing. These don't have to be expensive. This is like an decade-old thing, and this is something I bought for like $15 off of Amazon. Those don't have to be expensive. Through the design of the Hotend, you don't need extensive pushing forces to get a lot of flow. The next part in line is the cold end, and this has a very unique feature. It does have dovetail cutouts on both sides. So basically it does enable you to really easily put on stuff like height sensors or cooling ducts, basically you name it, and have a very tight connection up here because you can pretty much screw on the aluminum and press it on the opposing side. And you get a very rigid connection here. Having a look on the top of the cold end, you can see there are M6 threads. And you can use a slim M6 push style fitting to make it accept a Bowden tube. Or you can 3D print these inliners which thread in the M6 thread and offer you a liner, and these will fit into any extruder that is directly driven. So again, this is sitting on the dovetail on the opposing side. So you can pretty much just slide this out. Here on the front, you can see there is a 30 by 30 millimeter fan, which can be connected via M3 threads in here. And you have the same bolt pattern on the back. So mounting this to, you can also go this direction. You can do whatever you want with it. You could have that stand off a bit from any kind of carriage and just bolt it onto there very rigidly. Moving further, if we loosen these 3 screws, this is basically a flexure here in the aluminum, which clamps firmly around the heat brakes. If you ever rip those threads out, there is a seat for an M3 nut, so you can still use it. Now, you can just slide this one off and reveal the heat brakes. So my recommendation is to use this heat brakes single time use only, because once you screw them in, make sure to do that while the hot end is kind of hot. They form a tight seal with the mating surfaces. If you unscrew these, this will probably not make a tight seal again. I wrapped some tape around pliers so I could grab them from the top, and once this is hot, basically torque them down, and that worked out pretty good. What this enables us to do, if you leave those heat brakes in here, you can pretty much just hot swap these 2 different variants of the Hotend. You could also just use the 2X version on here, or 3X, or whatever I will be coming up with in the future. And yeah, just use 2 lanes wherever you want to put it. So this is basically very, very modular. Also, there are these standard heat cartridges, 6mm OD by 20mm of length. The 4X version does feature 4 of them, so it totals out to 200 watts of heating power, which makes it quite dynamic. For most of the 3D printer mainboards, you will need an external SSR to run these or switch the currents to these. If you don't want to go through all of that, just use 2 of those, and most of the standard boards will supply these kind of power. The thermistor is being screwed in here. This is the SLA printed cooling shroud, which just slides on and is being held in place by an M3 screw. But the later versions will feature this kind of lip up here. So you can basically mold a silicone sock or something and it will snap in place on this lid here. Coming to the star of the show, the Hotend. This is the exact same one here. We need more data points to get rid of the beta status. And I hope this will happen in 2025, and I could use all of your feedback regarding this thing if you want to build it on your own machine. I tried my best to have all of that downward compatible. So if you have this cold end installed in your machine, I will try to make everything fit in this ecosystem we've created. So you don't have to change out all the parts. You could basically just go ahead, order a different variant or same style with a newer version of it and just hot swap them. All of these hot ends, because they have a quite large melting zone of about 40 millimeters, I shaved off 10 millimeters from the previous attempt because as of right now, this is just really hard to handle that kind of flow and get it cooled down again in time. So I think let's do experiments before we turn this knob to 11. Also, there is a lot of stuff concerning the internal geometries and there's a lot of patterns going on, but I'm working on that. I'm 100% certain we're going to do another video on just this topic alone. So this variant will feature just round channels starting from top to bottom, but this will get you in the neighborhood with a good filament. My reference here is from Fiberlogy, their high-speed PLA. This will deliver up to 200 cubic millimeters a second. However, I found that the selected material is highly influential on the numbers you get. In one instance, I could get 150 cubes of flow with a certain PLA, but only 50 with a different brand. So we have to figure out what kind of filaments are favorable to this, but in all instances, you are way above what you get on your standard hot end on most of these printers nowadays. Last in line is the nozzle. I opted to go with the standard M6 wrap style nozzle. So you can basically screw in everything you want from the wrap catalog. From standard plain brass nozzles to hardened CHT ones, you name it. I did the conversion here. This is a Raspberry Pi 5 and this is the original Creality mainboard with added Klipper firmware. And this is somewhat mandatory for this project. You either have to use Klipper or Marlin in one of its latest versions to gain access to either Pressure Advance or Linear Advance. For this kind of longer melt zones, this tends to be necessary to dial those in, but it can give you some rough numbers for estimates. In terms of costs, by the time of filming, I don't have final pricing for the SLM printed parts, but I guess it will be somewhere in the 60 to 70 euro range for the aluminum parts if you buy the one-off and cheaper if you buy in bulk with your friends, etc. Heater cartridges and heat breaks will add another 30 for the 4X filament version, so before extrude a part you stay below 100 euros, the rest is up to you. But I'm pretty sure everything will be downward compatible and you can use the infrastructure for just swapping out to different variants in the future. One last thing, I did configure this with all the threads being recut after SLM printing, so my hope is that you don't have to do anything. But full disclaimer, I have never received a fully done version of this particular piece. So for the first versions, it would be smart if you have an M6 and an M3 tap on hand, as well as a 6mm drill or end mill, which you could potentially use to enlarge those holes for like heater cartridges, etc. So of course, my hope will be that in the future, these parts will be ready to deploy on the machine, but I don't have enough data points to state that from today's point of view. So, now it's your turn. The files and build guide are online. Go, build it, test it, break it. There will be a section on my Discord especially for this topic where you can post your builds and also get help on doing so. And if you link your YouTube videos somewhere down in the Discord, there will be a review video coming this end of the year where I'll go through all the footage and just basically have a look at what you guys did with it. And most importantly, give me all your crazy ideas. Colors, materials, geometries, what would you do with directional material deposition? And lastly, this is just the beta release. The platform will evolve, but the foundation is open. Forever. My name is Jan. I build stuff so you don't have to.